This video is going to demonstrate how to appropriately use the rule for significant figures for addition and subtraction. What we will do first is just simply state the rule and then try to demonstrate that with examples to give you some understanding. The rule simply says the most decimal places your answer can have is the least number of decimal places of the numbers that went into the calculation. To show you that, we're just going to give you a very simple example of, let's see, 15.236. I'm not sure I have my one here. It's 15.236 plus 11.1. That's going to equal 26.336. Now that's a relatively simple calculation. It's just adding ones to a couple different numbers, but you can probably figure out that we have too many decimal places here because of this number right here, this 11.1. This only has one decimal place. I need to have the same decimal places here. I can't be any more precise with this answer here than what I used to get that answer, which is the 11.1 over here. So this number would just simply round to 26.3 with the right number of significant figures. Pretty simple case. Really, we don't have to do any rounding or anything with that yet. We're going to go to a blank piece of paper here, and then we're going to try another one. We're going to go 5.23402 minus 1.22. That gives me an answer of 4.01402. Again, we have a lot of extra decimal places here. This is way more than what we need. What limits us? Well, that would be this one right here. We only have 2 decimal places there, which means we can only have 2 decimal places here. So now my new answer becomes just simply 4.01 with the correct number of significant figures. It does not have to have a decimal to create the right number of significant figures. For example, let's just say we would measure something very, very big. Like let's say we have a building. And this building was measured to the closest 10 feet, which let's just say this is what, 110 meters tall. And let's say somebody wants to put another structure on top, and we'll just say like a communication antenna or something like that. And they want to make this thing 15 feet taller. So they might have measured their closest foot. So there's 2 different types of measurement happening here. We're measuring to the closest 10 feet. We're measuring to the closest foot. So now if I add this together, I'm going to have 110 feet plus 15 feet. Now both of these look like they have the same number of decimals, but we don't know about this number 0 right here. This, when I do this, is going to simply give me 125 feet. Again, pretty simple number, but because of this number, we have too many significant figures. So this time we're going to have to round it up. We need to round it to kind of our 10th place here. This is the last known digit measured with precision. We know that this was at least 110 feet. It could have been 112. It could have been 113. We don't know this ones column. We only know the tens column. So we'd have to round this 2 up because, again, 5 would round numbers in general up to a greater number. So this becomes 130 feet with the appropriate significant figures. So it doesn't have to have a decimal. You got to go back to your rules about what is significant and not significant. And this 0 is not considered significant because it's a trailing 0 without a decimal. Maybe a better way to write this might be something like 1.1 times 10 to the second. That might tell us that there are 2 significant figures here. And this one might be like 1.5 times 10 to the first, or 10 to the 10th. And that might make that a little easier to understand, kind of that there's 2, we can move these over and make the decimals work, but a lot of times we'll just use our calculator to do the work without having to change the exponent. So hopefully that'll give you a good explanation as far as what happens with multiplication and addition and subtraction. You can't be any more precise here than when the least precise number over here. In this case, even though this number was bigger, this 110 feet was our least precise number. This was measured much more closely to this ones column. This was only measured to the tens.